Okay, here we go. Lesson 13, practice problems. Your athlete today is John Elway. There's his rookie card. We're going to try this coming summer. So summer of 2025, we're going to try to get this one autographed. So John Elway was a two-time Super Bowl winner when he was on the Broncos, and he had a great career. So anyway, John Elway, featured athlete. All right, here we go. Lesson 13, practice problems in right triangle ABC. Altitude CD is drawn to its hypotenuse. Select all triangles which must be similar to triangle ABC. Okie doke. So let's mark each of these angles. So we're going to go 1, 2, and then we got the 90. So that means that's 90 also. So let me zoom in here, but the key concept that you need on this one is the angle triangle similarity theorem. Hey Claire, can you close that door? Okay, so the angle triangle similarity theorem, that basically states, oh, okay, cool. In any two triangles, if there are two pairs of congruent angles, then the triangles are similar. So, let's look at A, B, C, the big one. So you've got the red, the black, and the 90, okay? So there's the 90, there's the red, and then you got this one with the 2 marks. Okay. That means that triangle CDB, this one right here, has the 90 and it has the black. So CDB is going to be similar to the bigger one. That also means that ACD has the 90 and the red. So in the bigger one has the 90 and the red. So those two are similar. So pretty much all the triangles are similar, so you just got to nail them. So in right triangle ABC, altitude CD, altitude, this is the altitude, is drawn to its hypotenuse. So right triangle, hypotenuse is always opposite the 90. Altitude drawn to its hypotenuse, okay? Select all triangles which must be similar, so it's going to be ACD, CDB. ABC also is going to be similar, of course. It's the same triangle, so it has the same shape. Let's see, ACD, yep. BCD, yep. Oh, shoot, order. We got to get the order right. Let me forget all this. Let's just go with check boxes. That's right, we got to get the order. Okay, so ABC. So we're going red, black, 90. That's A, B, C. Okay, so we got to get the order right. So for this one, it's going to be A, the 2 is going to be C, and the 90 is going to be D. So ACD is one of them. Okay, for this one over here, the red is going to be C. The B, and then the 90 is going to be D. So CBD. Okay. You got to get the order, so order matters also. So, yeah, I think that's it. Let's see. Can't say BDC if you start with ABC, right? ABC, you got to also select. So ABC, red, double, 90. You got to get the right order. So BCD isn't going to work. BDC is not going to work because it's out of order. CAD is not going to work because it's out of order. So these are your three. Make sure you don't miss the order. Okay. Number 2, in right triangle ABC, altitude CD. There's your altitude. With length H is drawn to its hypotenuse. So ABC, hypotenuse is always opposite the 90. We also know that AD equals 12 and DB equals 3. What is the value of H? So this one's tricky. You have to set up ratios of corresponding sides. So let's do what we did last time. We're going to color in this one red. And we'll go, let's just go black right here. Meaning that this is the red one. And this is 90, so this is the black one right here. Okay, and this whole thing is 90. Okay, so let's see. We got to figure out H. So what you're going to say is H over 12. So the smaller of the two over the bigger of the two, forming the 90-degree angle. So what's the smaller of the two on this one? 3, right? What's the bigger of the two forming the 90-degree angle? That's H. So once you set that up, you're good. You can just cross multiply. You'll get H squared equals 36. 12 times 3 is 36. Just square root both sides. H equals 6. Boom. Done. Tricky though. Tricky. So the key on this one is to set up the ratios of the corresponding sides. Because the triangles are similar, the corresponding sides will be in the same proportion, which we learned a few lessons ago. All right, so H equals 6. Okay, number 3. In triangle ABC, so ABC, which is not a right triangle, meaning that that thing's 75. This is obviously not a right angle. This isn't either. So there's no right angle, so it's not a right triangle. Altitude CD is drawn to side AB. The length of AB is C, okay? Which of the following, so which of the following statements must be true? Now, I'll be honest, I looked at this one earlier. The measure of angle ACB is the same as the measure of angle B. That is highly doubtful because this is a 90-degree angle. They share angle B, but there's no 90-degree angle in the larger ABC. So you can't say, so angle is out. So you can't say those two are similar, the small one and the big one. You can't, because they do not have two angles in common. So ACB measures angle B, no chance at all. B squared equals C squared plus A squared. Well, no, because it's not a right triangle. It doesn't have a 90-degree angle. So A squared plus B squared equals C squared doesn't work. In other words, A squared plus B squared equals C squared. It doesn't work. So anyway, triangle ADC is similar to ACB. No, because there's no right angle. Like, there's no right angle. So it's not gonna work. Right? Okay, the area of triangle ABC equals 1/2 the height times C, and that's the one we want because the area of any triangle is 1/2 base times height. So the area of any triangle is 1/2 the base times the height. So base is C, height is H. So that's the one you want, D. Which of the following statements must be true? All right, quadrilateral ABCD is similar to quadrilateral A prime, B prime, C prime, D prime. Write two equations that could be used to solve for missing lengths. Okay. You could say like AB over A prime, B prime equals CD over C prime, D prime. You could do that. You could say AB over CD equals A prime, B prime over C prime, D prime. So there's one. There's two. There's a lot of different ones that would work. Okay, segment A prime, B prime is parallel to segment AB. What is the length of segment A prime A? Okay, so I see an 8 and a 20. I'm thinking, yeah, these are parallel. That means that we got corresponding angles here and here, meaning small triangle is similar to the big triangle. So 8 times your scale factor equals 20. Divide by 8, divide by 8. Scale factor equals 20 over 8, which equals 10 over 4, which equals 5 over 2. So our scale factor is 5 over 2, from small to big, right? So what is the length of A prime A? That's a good question. So you would say 12 times 5 over 2 equals CA, right? Because 12 is going to be similar to CA. So 60 over 2 equals CA. CA equals 30. So this whole thing equals 30. CA. And if this is 12, that means this is 18. So A prime A equals 18. What is the length of B prime B? Well, that's easy. 6 times your scale factor, 5 over 2, will equal CB, the whole thing. 6 times 5 is 30. Divided by 2 equals CB. So 15 equals CB, meaning this whole thing is 15. So B prime B is 15 minus 6, which is 9. Tough problems. Wow. These are tough problems. Okay. 6. Lines BC and DE are both vertical. What is the length of BD? So both vertical. Okay. That means they're parallel. If they're both vertical, right? Therefore, we've got a transversal across parallel lines. So you automatically know this and this are the same. This and this are the same. What's the length of BD? Okay. So I'm going to figure it out by solving my scale factor. You're going to say 2 times your scale factor equals 5. Right? Divide by 2, divide by 2. These cancel. Scale factor again equals 5 over 2. So we're trying to figure out BD, which is like right here. What you can say is 3 times 5 over 2 equals AD. Because AD is the similar side to AB. So 3 times 5 is 15 over 2. So AD is going to equal 7.5. Meaning A to D is 7.5. So if you're trying to find BD, that's just simply 7.5 minus 3, which equals 4.5. So A is your answer. All right, number 7. In right triangle ABC, right triangle, AC equals 5. So the whole thing is 5. BC is 12. A new triangle DEC is formed by connecting the midpoints of AC and BC. So if these are the midpoints, both midpoints, then these are parallel. Meaning that we have similar triangles. So what's the area of triangle ABC? Well, that's just 1/2 the base times the height, which equals 1/2. 12 times 5, which 12 times 5 is 60. 1/2 of that is 30, equals the area of ABC. Okay, what's the area of DEC? Well, that should be pretty easy. Let me think. So if this is 12, the whole thing, and this is the midpoint, that means this is 6, and this is 2.5. They told us, like, these are the two midpoints. So you got to go 1/2 B times height, which equals 1/2. 6 times 2.5. 6 times 2.5 is 15, right? 6 times 12 is 2. 1/2 times 6 is 3. So 1/2 of 15 equals 7.5. So that equals the area of triangle DEC. Final answer, 7.5. Does the scale factor for the side lengths apply to the area as well? Wow. Okay. So what they're saying is, can you go 7.5 times your scale factor of 2 equaling 30? That's the question. 15 equals 30? No. So the answer is no. Because 15 does not equal 30. But we're going to get to something. 7.5 times the x equals 30. Divide by 7.5, divide by 7.5. X equals 4. 4 is the same as 2 squared, or your scale factor squared. But don't worry, we'll get to that. It's coming. Okay, now 7, 8. Quadrilaterals Q and P are similar. What's the scale factor of the dilation that takes Q to P? Well, Q is bigger than P, and we have 5 and 4. So scale factor is either 4/5 or 5/4. Because we're going from bigger to small, it is 4/5. All right, number 9. Priya is trying to determine if ADC is congruent to CBA. She knows the segments AB and DC are congruent. She also knows that angles DCA right here and BAC are congruent. Does she have enough information to determine the triangles are congruent? Yeah, because they share this side. So that's side, angle, side. So yes. Okay. It's getting harder. Come see me if you are stuck.